geometry, and it varies based upon the person. It seems like very rarely are people both really like both. Now, see, even myself, I'm a math teacher, but I would rather teach and do algebra, like the stuff we've done up to right now. That's all considered algebra, right? When you have numbers, you're given equations, and you plug it in and you go, right? The hard thing about geometry, and you're going to hear me say a lot of things about geometry, I'm going to have you write down inside your book, is geometry oftentimes makes you think outside of the box. It kind of dives into not really just a logical frame of thought, but it's more of a creative or an artistic kind of side of things, where you have to find things sometimes they don't ask you to find in order to find the answer they want you to find, which is confusing, right? But we're going to dive into this a lot. Geometry is good. Does anyone know, do you guys like geometry more than algebra, or algebra more than geometry? What do you think, Preston? Yeah, there is people. Usually if you're artistic, you like geometry more. Usually if you're more literal, and if you're not it's weird. I don't know how those two correlate with each other, but that's usually how it is. So today, from here on out, from here until the end of the year, we're into geometry. So we finished algebra, and we're going to start off pretty basic. So we're going to start off talking about different kinds of angles, which we've already hit today, was linear and vertical angles. So just to go over those, if I have a set of lines, so everything I write down today gets written down inside your journal. Capiche? Okay. Title it Linear and Vertical Angles. Okay, so we already know what linear angles are. Another thing you have to know about linear angles is we know they add to be 180 degrees. What is another name for that? What is a one-word name for add together to be 180 degrees? Yeah, you guys got to know this word, this chapter. Add together to be 180 is abbreviated supplementary. So if two things add together to be 180, they are supplementary angles. So anything that adds together to be 180 are supplementary. Vertical angles are always equal, right? That's all we need to know about vertical angles. Vertical angles equal each other. And I'm sorry I'm writing small. I just want to get as much as onto this. I know that's why I'm talking so much. Vertical angles equal each other. Linear angles add up to be 180 and are supplementary. Vertical angles equal each other. Okay, so let's start with this. Let's start with linear angles. Okay, somebody give me a pair of linear angles on that figure right there. Somebody raise your hand and give me a pair. 8 and 5 are not linear. What's a pair of linear angles? I like them. This is how you're going to write this. Angle 5 and angle 6. That's a pair of linear angles. They're on the same side of a line and they're next to each other. Okay, someone else give me another pair of linear angles. 4 and 3. Angle 4 and angle 3. Someone give me another pair. Angle 1 and angle 2. Give me another pair. Angle 8 and angle 7. Give me another. Oh, angle 5 and angle 7. Give me another. Oh, all right. Someone over impressed in this next one. Give me another. Shut up, Preston. Angle 2 and 4, 1 and 3 from the back row. Do we have them all? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Yep, that's all of them. Okay. So those are all examples of linear angles. All right. So angles that are next to each other on the same side of a line. And linear angles add up to be what? 180. Okay. Vertical angles. Someone give me a pair of vertical angles. 1 and 4. Angles that are opposite each other across two intersecting lines. 1 and 4. What's another? Give me the other two.
6, 7, 5, 8.
And those would be examples of the vertical angles. Okay, questions on any of that? All right, let's start doing a little bit of math when it comes to this. So I'm going to get these problems off your homework so you can kind of see what they're going to look like. So what it looks like is this. We're going to have two intersecting lines. It says this is angle 1, angle 2, angle 3, and angle 4. And it says that angle 1 equals 46 degrees. And then it says, I don't know why I wrote a random squiggly line. 46, and then it says we want to find angle 2, angle 3, and angle 4. So angle 1, I'll rewrite it again so you guys can kind of see it, is 46 degrees. So we know this one right here is 46 degrees. Okay, someone raise your hand and tell me what are the other angles. First hand up. Maddie? By what theorem is 346? Is it vertical or linear? Vertical. Okay, someone give me 2 or 4. Preston?
2 and 4 are both 134.
Good. So, Preston, tell me how you got angle 2 here.
Subtract 180 by angle 1.
Good. So we know that angle 1 and angle 2 are linear angles, right? So we know that if angle 1 is 46, angle 2 and angle 1 have to add up to be 180, so we can just subtract 46 from 180 to get 134. And if this is 134, then this one has to be 134 because they're vertical angles. All right? Okay, I want you guys do it on your own here. Try one of these on your own. So if I have another pair of vertical lines here, another pair of intersecting lines, and it says this is 2, 2, 3, 4, 2, 2, 3, 4. Angle 2 is 36. Find angle 1, angle 3, and angle 4. If angle 2 is 36 degrees, find angle 1, angle 3, and angle 4. Yeah, you're welcome. I peeked in there and saw you were in there, so I figured I was good.
Appreciate it. I should have checked in with you.
Okay. Trent, what's angle 1? 144. How do I know it's 144? How does angle 1, how do these two relate? By which one? Are they linear or vertical? They're, yeah. Which one? These are not vertical. These are linear. Now the reason I know is if 144 is they add up to be 180. Angle 4 is vertical. From there, so it's going to be 36, and angle 3 is also 144. Who got them all right? Raise your hand. Onward.
I totally did. I thought you said 2 and 4.
Okay. All right. Now we need to start looking at solving equations using this kind of method. So if I have two intersecting lines, and I want this one written down for sure, because these are where most people struggle with this. So if we have two intersecting lines, and this is Z, this is 7x plus 30, and this is 12x minus 5. So we have to solve for x and for z here. All right, so we have to identify first which variable is going to be easier to solve. Z is not. Even though z is by itself, z is not easy here. Because we can't find z unless we have x. Right? So, Kaysen, how would you go about solving this? Okay, you're on the right track there, but if we add up these two together, we're going to have two variables, right? Which means you can't solve them. So we have to do this where we only have one of them. What do you think, Derek? Getting closer. You're really, really close there. So what do we know about these two angles? What kind of angles are these?
Oh, yeah.
They're vertical, right? So what do we know about vertical angles? Vertical angles are the same. So in this case here, what we're going to do is we're going to go 7x plus 30 equals 12x minus 5. Now the reason why I can do this is because they're equal, right? Those two angles are vertical, so because they're vertical, we can set them equal to each other. All right? Yes. Any vertical angles, you can set them equal to each other. Now we can go through this and we can solve for x. So, who can raise their hand and tell me how to do this? This is back to math 1, but we need to solve for x here. How do I do it? Okay, so we want to move x over here, so we're going to subtract 7x. We have 30 equals 5x minus 5. Trey?
Isn't it 76 degrees?
I don't know, is it? How'd you figure that out? Did you get x equals 7? So x equals 7, but Trey's saying this whole angle right here is 76 degrees, which it's not, but good try, Trey. Really close, though. What's 7? So now in order to get z, we have to know what this angle is. How can I get what the measure of this angle is?
You times 7 by 7.
Yeah, we just plug it back into this. So we already know what x is, so we just plug it back in. And we get x equals, this whole angle is 79 degrees. Okay, so how can I get z? Yeah, 180 minus 79, which gives us, is that 101? So we know that this degree here would be 101. And there's our two angles, right? There's our two variables. Let's do another one like that. Where we have to solve for stuff. So if I have two intersecting lines, and I'm told that this is 10x minus 61, and this is 5x plus 1, and that's z. So we need to know what x equals and what z equals. So this one's a little different. Someone raise your hand and tell me how to do this one. How would I get x first? You can't get x and z together at the same time. We have to get x first. So how do we do it? Maddie. Getting closer, but no, you can't do that because that doesn't help us find just this. We have to do something with these two angles. And do what with them? What? Okay, we're getting closer, really, really close. So what do we know about, what kind of angles are these? Linear. What are linear angles? They are equal to 180. So what we can do here, because these two angles are linear, we can add them together and set them equal to 180. Everyone see that? So because those are linear angles, we can add them together and set them equal to 180. Now we can go about solving this. So, if they're on the same side of the equal sign, all we do is combine them. So 15x minus 60 equals 180. We're going to add 60 to both sides to get 15x equals 240. And I'm going to need help. What's 240 divided by, no I don't, 16? So I think x equals 16. If someone wants to check my math, they can, but I'm pretty sure. Yeah, I'm right on the money. Okay, so 16. So x equals 16. Now, here's the question. So we have x. In order to get z, we have to know x. So which one of these would you guys plug them back into? Yeah, why would you plug it into this one? It is easy because this angle equals this one. Now, could you plug it into this and still get z? Yeah, you could plug it into this and then subtract from 180 here. But by doing it, by plugging it into this, we know that this angle equals this. So we can go 10 times 16 minus 61, or 160 minus 61, or 99. So we know the measure of this angle is 99, which means that one has to be 99. And I am, something is definitely wrong with that. What the heck? And there's your solution. Kind of cool, right? Okay, you guys ready to try one on your own? I haven't created the assignment yet, Casey. Don't get antsy on me. Computer, Casey. All right, here we go. Here's our two things. 8x plus 88. 13x plus 73. And z. Go for it. Well done. Getting closer. Nice. What do we do with the x's? What do we have to do, though? Yeah, why do we have to set them equal? Because they're vertical angles. So we have to set them equal. So if anybody was struggling with that part, there you go. You want to know the other thing I love about geometry? You can't use photomath. Life's so much better. Now the real math students start to rear their heads. Trey's like, I better start paying attention. Just kidding, Trey. Alright, so we set them equal to each other. We get 8x plus 88 equals 13x plus 73. We got to get the x's on one side, so we're going to subtract 13x to both sides to get negative 5x plus 88 equals 73. Subtract 88. Negative 5x equals negative 15. Divide by negative 5, and x equals 3. Do we know what x equals? Sure. Okay. All right, Trey, this is the most important question of the day. Which one would you plug x back into? Good. Could you plug it into this one?
Yeah,
Could you plug it into this one?
yeah,
Why can you plug them into either?
because you can,
Well, why though?
because,
They're the same, right? So 8 times 3 equals it plus 88. 24 plus 88 gives us that angle is 106, is that right? Yep, no, 112. Someone needs to correct me when I say stupid stuff. 112, which means that this angle, these two angles are linear, so we can add them up. We can basically go 112 plus z equals 180. Subtract 112 from both sides. Z is going to equal 68. Who got them both right? Raise your hand. Oh, Trey. Thought we were best friends, man. Okay, your assignment's there. Go.